Hi everyone, new video today on RCAC Learning Center. We will be talking about quantity takeoff and sustainability. In this video, we will be using our tool ReoMark to quantify the reinforcement and in a slab as well as in columns using Grade Calc tool in RCalc. But before that, we will just talk about the life cycle of the project, typically in the New South Wales industry, where you are in a consultancy office. You're dealing with DA stage where you receive architectural drawings or a scheme which is typically yield driven. I mean, the maximum number of units will have to be squeezed in a floor plate, which is typically in the residential market 1,000 square meter per floor, circa 10 apartments per level. So the focus of the architect and behind them, the developer is squeezing more units, and then they give those drawings to the structural engineer, who is going to provide the proper column grade and lateral system, slab thicknesses, as well as transfer structure, where the column grade doesn't land in a favorable scenario for parking. So you'll have essentially parking grade, typical story grade, as well as probably commercial in the middle, bottom few floors under the residential. Now, what happens while you're doing this? You're giving the architect the layout, and you keep iterating until the system is locked in, and your client, who is typically is the builder, will be trying to maintain the yield while we are doing that, and minimizing construction cost, the member sizes, and similarly everything that comes to the play when you are talking about the dollar. Sustainability targets, if the project is a green star, will need to be met in this very important stage. You get DA approval, and then you come to the detailed design stage, where the architect, as a lead consultant, together with all of other consultants on board, finalize the design, take it through all of the particulars, something like MAP, ducting, compliances, and while doing this, the structural engineer, us, we try to maintain whatever we had in the DA condition. Architect will have like an agenda to keep the yield and the layout similar to what was approved in DA, so they don't need to submit 455 like, which is modification or amending DA. And the structural engineer will need to maintain or reduce the member sizes, because typically in a preliminary stage you go a bit more conservative, and you keep iterating in this cycle until you finish the project. So most important there is how you quantify your quantities in a structural system. Most important is the slab. So when you're looking at um, the project quantity, most of the quantities will be in a typical floor. When it comes to the concrete definition or concrete distribution, concrete will be in the slabs, a little bit in the columns and walls. Like, let's say the slab will take more than half of, if not 70% of total quantities. And when the building gets taller, it will become the walls and columns become more pronounced, which is something we call the premium of height. Um, Direct into the tool, which is ReoMark. This is a floor plan that I have prepared beforehand that shows all of the reinforcements in the building, which is RC slab in this instance. If you are clicking on Analyze, you'll get all of the quantities and the slab rate in this project. So what happens if you click on a report? There you get a detailed report with the quantity takeoff for all of the rebar type, being top, bottom, integrity, and similar. I will walk you through now how you draw the reinforcement. So in this example, I will just draw the bottom reinforcement mat to show how convenient this tool is. First things first, the slab is 230 thick with the as an average. So let's see how we do it. So we are activating now the bottom layer, and then we go straight bar. Let's say I'm gonna draw here, activate polar because the building is like rectangular. It will lock in the bar length by 12 meters, and then you draw the extent. So let's say you've got the extent from here all the way to there, and then you enter the rebar diameter, let's say 12 at 200, so it shows you the extent and how the bar is distributed. Click on this toggle, you will hide and show the extent of the rebar, but this is very useful so you know you've covered the slab altogether. Now we draw another bar from here to there. You don't worry about the extent for now because I'm intending to loop this reinforcement from here to there. Just click enter, so it is already looped. If you have an issue with the length of this bar, so you can make it shorter. And then the other bar, which is from here to there, um, with the mouse scroller, you just increase the extent and then hit enter and cover the remainder of the floor. So we go from here to there, enter. And now I will continue with this floor and speed up the screen to save time. Now reinforcement has been drawn. We can now just click on analyze the icon there. I will give you a full breakdown for all of the reinforcements. Now, if you noticed, I haven't put articulate the reinforcement, but now the work starts essentially. So where you want, for example, to look at the top reinforcement, bottom reinforcement, where is the distribution of rebar? Let's say my bottom reinforcement here being long spans should be 16 at 200, for example. So I will edit all of that using this icon, which is edit rebar. All of the reinforcement have been converted to 16. If you have certain areas, for example, in here, you want more reinforcement or less reinforcement, you can immediately change that based on whatever your design is going to be. Now you click on this, so immediately you see the impact on the Rio rate or the bottom tonnage. Now you go to top or integrity reinforcement. I have drawn it here using the same ways of drawing the bottom reinforcement. That would be on its own is 4.7 ton in this scenario, being 12 at 200 for integrities. Is if, for example, I've added as well the U bars on the perimeter, which is something can be drawn easy, just like every other bar. If you don't want it, you can delete it. Now, if you go to the top reinforcement mat there, here we've got N12 at 300, for example. If you are changing this to be 16, you will double the reinforcement or more than double the reinforcement. Here where your articulation and thinking of the reinforcement comes into the play. And then additional top reinforcement, if that is N24 at 300, you can change whatever rebar you've got. And this slab is not PT, but you can always put PT. Let's say you've got PT from here all the way to there. I've limited the length of PT for 30 meters. And let's say the spacing of PT, how many strands you've got, let's say 3. So it will show you the distribution of PT in this example. Now we click on analysis. So it will give you the full breakdown for the whole thing. And then it will tell you how much carbon emissions you've got in the project. And then again, generate report, you'll get the whole breakdown with each and every floor drawn with the rebar mark, let's say ID number N29 there, you can look into it and see where is N29. That is integrity reinforcement. These are the diameters. This is the total length of all of the bars. Super important tool for everyone to be ahead of the game when it comes to getting the quantities right at the beginning, because typical scenario is like you start with very high quantities and you get a challenge, or more typical scenario is you try to please your client by putting very tight quantities, and then you spend all of the project and the money that or your fees trying to maintain those quantities. So without clarity on those numbers that are like industry expectation as a ballpark, let's say for PT 6 kilogram per square meter. With a PT slab, you need to have something like 65, anywhere between 55 and 65 kilogram per cubic meter and similar. Or if you have the slab being reinforced concrete without PT, you're talking about 125 to 135. If you commit to those numbers without doing proper math, then there will be a problem because each project has its own merits. For example, end spans are too many, or the slab system is screaming. You not, for example, provide a column grid that is appropriate for PT slab or RC slab, where the column grid is an important thing. Now we finish with the slabs. You can use another tool, which is rate calc there for concrete sections, which is super useful as well, where you can get any column. Like you see the size there is shown on the right side, and then work out the reinforcement ratio on those. So draw the reinforcement for the column, however it is designed for, and then enter the rebar diameter, those the blue ones, uh, um, for let's say 32 here, which is too much. And then we say you've got stirrups, let's say 300 spacing, and then this is the length of the element of the column is 3 meters, so the length of the rebar would be 4 meters, because you need to count for the lap above the slab and throw it into the rate of the column. This tool as well works well with band beams. If you have a band beam of this width and you have stirrups um, in whatever direction you want them, you can do that to the left or to the right. It works the way you wish. And if you have as well circular columns, you can use this tool to get it done rather than Excel sheets. This example will be uploaded to the RCAC Learning Center. Thank you very much.